everybody, and welcome to this video on calculus. In this video, we're having a look at what is a tangent of a function. So a tangent is a straight line that intersects a function at one point, and at the point that it intersects it, it has exactly the same gradient of that particular function. So for example, if we have a look at this picture over here, at this point they intersect. The F is our graph and the blue line is the tangent, and at that point the graph and the tangent have the same gradient. So what we're going to have to do is get the equation of the gradient of the tangent. So the tangent, what we note, it is a straight line, so it has the formula y is equal to mx plus c. So we want to get what is the gradient, and we need a point to substitute. So the gradient of the tangent is where our calculus comes in. To calculate the gradient, we evaluate the derivative of the function at that point. As we spoke about previously, the derivative is the gradient at a particular point. So that would be the gradient then of the tangent. And then we substitute that point that they intersect at, which is x and f of x, that coordinate that's on F, and then we can get the equation of the straight line. Let us have a look at an example. So over here it says get the tangents of the following. So there's two graphs. The first one is f of x is equal to x squared plus 3x, and we're looking for the tangent at x is equal to 2. So first of all, let's go ahead and find the gradient. The gradient is when we get the derivative of the tangent and evaluate it at, well, in this case, x is equal to 2. So first, let's go ahead and get the derivative. It's 2x plus 3 using the derivative rule from the last video. And in particular, we want to get the derivative evaluated at 2. So it's 2 times 2 plus 3, which is 7. So that is our gradient. The next thing we need is a point. So we know the x coordinate is 2, so we want the y coordinate. So to get the corresponding y coordinate, we substitute the x coordinate back into the equation. So then that's going to be 2 squared plus 3 times 2, and that is 4 plus 6, so it is 10. So our coordinate that we'll substitute is 2 and 10. So now we want to get a straight line with a gradient of 7 and going through the coordinate that. So we substitute the gradient is equal to 7 and our coordinate 2 and 10 into our straight line equation y is equal to mx plus c to solve for the y-intercept. So in the place of y, we're putting 10 from the y coordinate. In the place of 7, the gradient, we're putting 7 and the x is 2. So we then solve for c being equal to minus 4 if we solve for that. So therefore, the equation of our tangent is y is equal to 7x minus 4. Okay. So let us have a look at the next example and go through that process again so you can get used to it. So if we have to get the tangent, this time the equation is slightly different, and at x is equal to 1. So once again, first of all, we're going to go ahead and get the gradient, which is the derivative evaluated at that point. So the derivative of g of x is 3x squared plus 2. Then we're going to evaluate it at that x point to get the gradient at that point. So 3 times 1 squared plus 1, which is 5. So our gradient is 5. Now we need to find the point. We already know that x is equal to 1, so we want the y coordinate. So we evaluate it at x is equal to 1. So it's 1 cubed plus 2 times 1 plus 6, which is 1 plus 2 plus 6, which is 9. So our coordinate that lies on the tangent and on the graph is 1 and 9. So all we have to do is now find the equation. So we substitute our gradient being equal to 5 and our coordinate into y is equal to mx plus c, and solve for c, the y-intercept. So in the place of y, we have 9. In the place of m, we have our gradient, which is 5. In the x, we have 1, and then we have c. So solving for this, we get that c is equal to 4. So therefore, our equation is y is equal to 5x plus 4. This is the equation of the tangent. Please make sure you've understood this video and these concepts. It's very important. And please watch our other videos on calculus for more information. Thank you for watching, and please subscribe. Bye.